You don't have to write these down, but just a little quiz, because we've been solving equations. And we've been solving equations for a long time, but we just solved a new type of equation this year. What's x? Sorry? 16. Add 16 to both sides. What's x? Move 16, move the minus 16 to the right. You get x squared is equal to 16. You have to take the positive and negative square roots. And you get plus minus 4. What do you think x is?
4.
4? So you're telling me the square root of 4 is 4?
No.
How would you get x by itself? Don't we always get rid of what's around the x? So what's around the x? How do you get rid of a square root? Square it. And it cancels those out. Well, whatever you do to one side, you got to do to the other. So x is going to be 16.
That makes no sense.
Okay? That is the basics of radical equations. What's a radical equation? It's an equation that has a radical in it. Okay? How do we solve radical equations? Well, at some point, we still solve it the same way. You're still trying to get the variable by itself. But at some point, we're going to have to get rid of the square root. So let's look at, before I write down anything up top here, let's look at this one. Don't worry about the rest of the instructions. We'll talk about this in a second. How do you think you'd go about solving this one?
Weird.
Yeah? Would you square both sides right now?
No.
Or what would you do? What might you do first that might make life easier on you? Get the square root by itself. So what we want to do is we want to move the 5 to the other side by subtracting 5. So when we do that, we get the square root of 2x minus 1 equals what? 7. Now we don't want to add 1 to both sides. We don't want to divide both sides by 2 because all that stuff is under the square root. So we want to get rid of the square root next. How do we do it? Just square both sides. And the square and square root will cancel each other out. Okay? So square both sides. To get rid of the square root. What does the equation look like now? What does the left side look like? 2x minus 1. What does the right side look like? 49. Now, it's just a regular equation. And what I mean by regular is like linear. There's no x squared. We don't have to take the plus minus square root. We don't have to factor. It's just one of those ones that we've been doing since grade 9. How do I solve? Add 1 to both sides, and then divide both sides by 2. You guys, a two-step equation like this should be automatic to you now. Automatic, you should know what to do. So how do we solve radical equations? Get the square root, and really by radical, we're talking about square roots. Get the square root by itself, get rid of anything outside the square root on that side, then square both sides, then solve what's left. Okay. However, there is one extra thing we must do with radical equations. We must check our answers. We must check by substitution. Because, and we're going to find this out in another example, sometimes when you square both sides, you're going to get a solution or a root that actually is not a solution or a root. Squaring does that sometimes. It's like a fake answer, right? Which is why you must always check, okay? And what do we call an answer that we get, but when we check it back in, it doesn't work? That's called an extraneous root or an extraneous solution, okay? So and remember, into the original equation. Like you don't substitute it in here, you substitute it back in the original. So when we plug it back in the original, we're going to get 5 plus square root of 2 times 25, which is the answer we've got, minus 1. Does that equal, so I put a question mark over the equal sign, 12? If it does, it's a good solution. If it doesn't, there's no solution. So let's calculate this side. 2 times 25 minus 1. Square root plus 5. It's good. Okay, which means this is a good solution. It works. Yes.
So, like, if it isn't right, what if it's like wrong? But like sometimes it's a solution when you actually get it wrong. Like you're saying.
Yes, it is possible to do that. Like you make a mistake and then you think there's no solution.
Would it be a half mark? Like,
Let's not worry about how many marks it's going to be. Okay. Okay. Let's just, so this is why what you want to do. I mean, you want to redo questions like that. Okay. Like on a separate piece of paper, cover up what you got, because chances are it'd be very difficult to make the same mistake twice. So if you do make an error the first time, if you check it over, you good chance of picking it up. Okay. Okay, so now we can go back up here. And just sort of talk about what we did. Okay. When we solve radical equations, we must make sure to identify any extraneous roots. And what is an extraneous root? And remember, root means the same as solution. It is a solution to the equation that is actually not a solution when you check it by substitution. So that's something new. I mean, you can always check solutions no matter what the equation looks like. Okay? Like with regular equations, we could check them to see if they're right. Okay? But usually, I mean, there's no extraneous roots in regular linear equations. There's no extraneous roots in quadratic equations, but there could be ones in radical ones. And we're going to see an example of that right now. Anybody still need this? Okay. Anybody good? Okay. This one. And you'll always be given, when you're asked to solve a radical equation, you'll be asked to solve it, you'll be given the equation, and you'll always be given this, check for extraneous roots. Don't forget to do that. It's part of the solution. So what do we want to do here first? We want to square both sides to get rid of the square root, but is there anything I should do first? Add x to both sides. Get rid of that minus x with the square root expression by adding x. So we get the square root of 5 minus x equals, and I'm just going to write it like this, x plus 7. What do you mean skip? 7x? It's not 7x. It's x plus 7. So no, don't skip it. Okay. Now what? Square both sides. Now, you have to square the entire right-hand side. What is x plus 7 all squared? And I'll give you a hint. It's not x squared plus 49. You don't square each term. You have to square the entire binomial. What does it mean to square a binomial? What does it mean to square anything? Times it by itself. So this means x plus 7 times x plus 7. Very important. That's 4 multiplications. So that side's pretty easy. It just becomes 5 minus x. This side, we've got to do some multiplying. What do I get? Yep. Plus 7x. Plus 7x. Yeah, can you give me the simplified answer to that? Yeah, because you can put the 7x and 7x together, right? So x squared plus 14x plus 49. Okay? Well, this is why we do these things. Okay, so square root's gone, so we're ready to solve. But is this a regular equation? It's quadratic. And it's got an x term, which means how do we have to solve it? Really? You want to do the quadratic formula? You don't want to do something? You want to just jump right there? Let's see if we can factor it. But before we factor it, what do we have to do? Everything to one side. Do you want to move all of this here or all of this here? Why? Yes, but there's also another reason. What's that? Yes. Well, the reason I'm thinking of, if you move this here, it becomes negative x squared, right? Yes. That's hard to work with. The x squared is positive here, so let's move everything with. Okay, so plus x minus 5. So when I move both of those over, I get 0. And what does the right side look like now?
X squared.
Plus 15x plus 44.
Ugly numbers. Oh. Yeah, it's
Okay, thank you for sharing.
You're welcome.
You can do it.
What? Wait, I think yes, you're E. Oh, you can? Wait.
Give me a pair of numbers that multiply to 44. Add those.
15.
Oh,
They just don't look like they friends, but they are.
they are friends.
Hey, wait. Why am I doing
Therefore, what are my two answers?
11 equals 4.
Whoops.
Equals negative 11.
So x plus 11 equals 0, so x equals negative 11
Negative 4.
or negative 4.
It's already checked.
Yes.
Triggered.
Now we have to check each one. I don't care if you're triggered. Okay? So, let's start with negative 11. Does the square root of 5 minus negative 11 minus negative 11
Great.
equals 7? Remember, plug it back into the original.
Okay, so 5 plus 11 minus 11. I'm thinking of what else, sorry. Oh, 5 plus 11 plus 11.
Okay, so I'm triggered.
I got 27.
You get 27?
Negative.
Yeah.
That's unfortunate.
Okay, no. Well, 11 plus 11.
You know what? Do you think, don't we have to do the square root?
What's square root?
Oh.
No. 5 minus 11.
5 plus 11, square root plus 11.
Wait, what did I get?
You know what?
What?
That don't equal 7.
That's times.
What do you mean times? That's subtract negative 11.
No, with the 5.
5 minus negative 11
16 squared is 4 plus 11.
is 15, which does not equal, which means
4.
that's rejected. Hey, it may not work either. We don't know. This is why we got to check it. So 5, subtract negative 4, and then you take the square root. Subtract negative 4. Does that equal 7? Well, what's 5 subtract negative 4? 9 square root. 3 plus 4. Yeah, that one works.
Good job, guys. Yes.
So negative 11 is what we call a what? Extraneous root. Good. Okay. So obviously this one takes quite a bit of work. Okay.
We work with keywords on the test.
Don't worry about what everything's worth on the test.
It does.
It's actually really easy. What do you think you'd do?
I think square root.
Yeah, because we got a square root on either side. Can't we just?
I got yours in this.
What does it look like after we square both sides?
X plus 5 equals
Is that a quadratic equation? Really? So it's just a regular equation. So we just got to get x by itself. But we got to bring the x's together first. So how do I take this from here? Over here.
No. No.
I'm doing it that way.
-4.
Minus 4x. That's fine, it'll still work. So if I do that, I get negative 3x plus 5 equals negative 1. Now what? Minus 5, so I get negative 3x is equal to negative 6. So therefore x is? Good. So when there's a square root on either side, it's actually pretty quick. Now we have to check it. And again, remember, check it in the original. Does the square root of 2 plus 5 equal the square root of 4 times 2 minus 1? What's the left side work out to? Sorry? Square root of 7. Don't bother taking it because you can't do it exactly. See if this works out to the square root of 7. Yes. So it's good.
How do we know? I know that it's 7, but like why 7?
No. This is not connected to this. This is what you get when you plug 2 in.
Oh, both sides would equal the same.
Yes, they have to.
Okay, I get it. I was confused because when all the other ones were related to that.
Okay. Let's look at a problem situation.
Yeah, just physics or math.
Calm down. So a guy named Francis Beaufort created a numerical scale to help sailors quickly determine the strength of the wind. And how this scale works is you get a number on a scale from 0 to 12. 0 being obviously no wind, 12 being, yeah, there's a lot of wind. How do you calculate this wind scale? Well, you have to get the wind speed. You have to know what the wind speed is, and then you plug it into this formula that involves a square root. Okay? And then you round it to the nearest whole number, and that gives you your scale. Tells you whether it's mildly or not windy, mildly windy, moderately, severely. Not necessarily, no. Okay, so if I tell you that V is 40, how would you calculate V? Yeah. V equals 1.33 times the square root of 40 plus 10. Right, so there's no solving here, you're just calculating. And when we deal with word problems, this is where we can go to decimals, because you can even see decimals in the formula. So, well, the square root of 40 plus 10 is equal to the square root of 50. Now you can use your calculator by doing 1.33 times the square root of 50 and then subtract 3.49. And round that to the nearest whole number. What do you get? 6 is correct. So that means the scale is 6. Well, it's about halfway from 0 to 12. So I guess we would call that moderately windy. Okay? Yeah. You can just round it right away. Yeah. In this example, yes, because the scale is from 0 to 12. They're whole numbers. Yes. Okay, what if you were given the scale number and you were asked to find how fast the wind is blowing. Work backwards or solve. So this time I'm given B is 7 is equal to 1.33 times the square root of V is the unknown. And I have to solve for V. So this is a radical equation. Well, I know it's going to be faster than 40 kilometers an hour. Why? Because in the previous question, 40 kilometers an hour was a scale of 6. This is a scale of 7, so it's obviously going to be a little bit higher. But we don't know how much until we solve. Okay, so we got stuff around the square root here. What do you want to get rid of first? No, you can't get rid of the square root first. You've got to get rid of this or this first. You should know which one. What's that? Can't hear you. Add 3.49 to both sides. And you're going to get 10.49 equals 1.33 times the square root of V plus 10.
Minus 1.32.
No, come on.
What?
This is not plus 1.33. How do you get rid of that? Divide it, because it's being multiplied.
Think about your account.
What's 10.49 divide 1.33? Go 2 decimal places, since everything's to 2 decimal places here. 7.89. Okay, thank you. Now what? Square both sides. $7.89 squared, 2 decimal places again. 52.25. 62.25 is equal to V plus 10. Almost there. Subtract 10. Therefore, V is going to be 52.25. Don't forget your units. We're calculating wind speed here. Wind velocity is equal to V. Normally, you would have to check it, right? But usually with problem solving ones, we'll forget about the check. Okay. Okay. So that takes care of unit 3.